One of my favorite properties in math is the distributive property. And the reason I like this property is because we can use it to simplify expressions. We can use it to make problems earlier. So let's talk about what the distributive property is. Let's say we had a rectangle, and it says here whose width is 4 and whose length is x plus 2. So our width is 4, and here's what we mean by our length is x plus 2. We don't know how long x is, but we could represent it like this, x plus 2. We'll say this is x here and this is 2. So if we wanted to find the area of this rectangle, we literally could just go 4 times, well, x plus 2, because remember the way we find area is length times width. Another way we could do it is to think of these as two separate rectangles. Now if we did this, we could say again our width is 4, and our width is 4 on this rectangle, and we could say that this length is x and this length is 2. Because if we combine these two, we'd have this rectangle here. So we could say the area of this rectangle is just 4 times x, and the area of this rectangle is 4 times 2. If we wanted the total area of both rectangles, we would add it together. So we could have 4 times x plus, this should be 4 times 2. I'm getting ahead of myself here. And that would be 8. Okay. Notice, especially right here, 4 times the quantity x plus 2, we're really talking about the same area as 4 times x plus 4 times 2. That leads us to the distributive property, and I apologize again for this being crooked. You should be familiar with the distributive property. We've talked about it in the past. But what we have is we have to make sure whenever there's the distributive property, which means we have a number being multiplied by a sum here, some number times a quantity, we have to distribute the a to the b and the a to the c. That's how we get a times b plus a times c. And it doesn't matter if the number is written behind it. We're still going to go a times b or b times a, and a times c or c plus a. And the same thing is true for subtraction. So let's see how we can use this idea of distributive property to simplify and solve problems. Notice the directions say use the distributive property to rewrite the expression without parentheses. If you look at this example here, we have 3 times the quantity x plus 1. If we want to rewrite that without parentheses, we need to distribute the 3 to everything in parentheses. So often I see this. I see people get this part right and they say, oh, okay, we can multiply 3 times x, but then they just say plus 1. Well, but remember, 3 is multiplying this whole quantity here, this whole sum. So not only do we have to multiply the 3 by x, but we also have to multiply the 3 by the 1. Which, well, we don't know what x is, so we have to just leave it as 3x. But 3 times 1 is 3. Again, this is a very important skill we need to have when simplifying and solving equations. If you look at this problem here, kind of thinking of the same idea, this time we have a difference, this quantity being multiplied by 7. Distribute the 7. 7 times x, 7 times 2, which is 14. But in this case, there's a minus there, so we can have a minus there. If you like to think of this in terms, change everything to addition when it's subtraction, that's not a bad idea. If you go keep, change, change, you would get 7 times x and 7 times a negative 2, which is a negative 14. Plus sign, plus sign. And remember, subtracting 14 is the same thing as adding the opposite of 14. Looking at our next example here, same idea, distributing to everything in parentheses. We get x times 2, which we write as 2x, and we get x times 5x. Now that's like saying 5x times x. So we have 2x Be careful before you start combining any of these terms, because x times x, remember, how many x's are there? There's 2, so that becomes 5x squared. And same thing down here, d times 2. We could write as d times 2, but it's probably better to write 2 times d. And d times d, well, that's going to be d squared. Subtraction sign here, subtraction sign here. And what we're going to talk about later is how these are not like terms because they're not identical. X squared means something different than x. Let's look at a few more examples. Again, we're just rewriting the expression, and you might be thinking, why do we need to rewrite it? Well, it'll become important later on when we have to simplify expressions. Negative 6 times x is just a negative 6x. Negative 6 times 3, well, that's going to be a negative 18. Okay, again, if you were to write this as negative 6x minus 18, that would be okay. Adding the opposite is the same thing as just subtraction. Okay. Moving on, looking at this example, feel free to pause and practice any of these at any point, so if you want to see how you're doing. Negative 3 times 3 equals negative 3 times t is a negative 3t, plus sign, negative 3 times 2 is going to be a negative 6. Be careful when we start dealing with negative ones and minus signs. You do have to be really careful. If you go negative 1 times 1, you get a negative 1. And then negative 1 times x is a negative 1x. Minus sign, minus sign. Now you really should never leave it as minus a negative. That's just difficult looking. But if we go keep, change, change, we get a positive 1x. And honestly, we really don't even need to write that 1 in there. We just get a negative 1 plus x. And one more example. Again, as we move on in math, a lot of things aren't changing, but the types of numbers we deal with are different. So we're going to deal a lot more with variables and negatives in algebra. If you go negative 4x times 2x, and let me just write that out. Negative 4x times 2x, and we'll come back to simplifying that, minus negative 4 times 3. Again, if you want to do keep, change, change originally, you can. And this is negative 4x times 3. You don't have to write down this step, but sometimes it's helpful. If you just look at this here, you multiply what you can. Negative 4 times 2 is a negative 8, and we have x times x, which is x squared. Over here, negative 4 times 3 is a negative 12, and then we just have 1x. Minus sign, but remember, you should never leave it as minus a negative. So if we go keep, change, change, we get negative 8x squared plus 12x. Now this is usually how you're going to use a distributive property when you're given a variables and we want to simplify an expression. But we can also use the distributive property to help us with mental math. If you look at this example, it says you want to buy 4 new tires for $44.98 each. Use the distributive property to calculate the total mentally. Well, let's just write down what we'd be thinking. We want 4 tires and each one costs $44.98. Now, you probably can look at this and say, well, that's about 4 times 45. And maybe you could see, well, 45 times 2 is 90, and 90 times 2 is 180. So you're maybe thinking this is approximately $180. And you'd be right. But we can figure this out without coming up with an approximation. Notice that $44.98 is really close to $45. In fact, it's just 2 cents less than $45. So if we rewrite $44.98 as 45 minus 2 cents, and then multiply it by 4, we can use the distributive property in our heads to come up with this. Like we said, 4 times 45 is 180. But we want to subtract this. Now what is 4 times, well, I think of it as 2 cents. 2 hundredths. But if you think of it as 2 cents, well, it's 4 times 2 cents, or 2 hundredths. And hopefully you can come up with 8 hundredths, or 8 cents. Now if you subtract that, we know we have $179, and then if you take 8 cents away, from that dollar, you would get 92 cents. So our exact cost, of course, before tax or anything like that, is $179.92. So this is just showing how we can use the distributed property not only to simplify algebraic expressions, but also to help us solve mental math.